You're not gonna be here Friday.
No, I'm here, yeah.
You won't be here
Are
Friday.
you gone Friday for content?
Yeah, I'll be gone Friday. I'm gonna be in
So, those people that are gone Friday, I'd like you to take your quiz first.
I'm gonna be on Thursday.
Thursday and Friday, okay. Well, we can see, I mean, technically I'm teaching today and tomorrow, and the rest of the week is review, so if you were ready to take it Wednesday, you could, otherwise.
Actually, I'll be here till 10 on Thursday, so I can just sometime before.
Yeah.
This is.
Yeah, that's. Alright, let's take a look at our first problem. So, we are solving equations that either have a rational exponent, which we learned, well, we've learned before, but we reviewed Friday that that is the same thing as a radical, or it'll already have a radical in it. With these problems, our steps are going to be very similar every time. The first thing you want to do is isolate your radical. Okay, we need that radical on the side by itself. So, if I want to get this cube root by itself, what would I have to do? Add the 2 over. Second step is raise each side to a power. To cancel the radical. Right, if you want to get rid of a third power, what would I do to each side? Cube it. Okay. So just for the sake of our example here, I'm going to rewrite just to show you what I'm doing. So second step, I'm taking each side to the third power. Then we solve. So a cube root and a cube will cancel one another. So that just gives me 2x minus 4. 2 to the third is 8. Add over the 4. Divide, and x is 2. Final thing we have to do here is check. When you start raising each side to a power, you will frequently get answers that don't really work. It happens mainly with even roots, because if you take 6, yeah. If you take each, like a negative and square it, it becomes positive, and so that can cause problems sometimes. So my rule is just check all of them. So you're just plugging it into the original. You don't necessarily have to show me work. You're welcome to plug it in on your calculator and check them. I don't care. If we put in a 6, that's 12 minus 4 is 8. Cube root of 8 is 2 minus 2 equals 0. So this one does check out. So 6 is our answer. All right. I want you guys to try one. So you guys solve this one for me. All right, so my radical's already by itself. Opposite of a cube root is a cube. So if we cube each side, 2t minus 1 equals 1. So 2t equals 2 and t equals 1. And when you plug it in to check it, you get the cube root of 1, which is 1. So that one's good. All right, let's try this problem. So step 1 is isolate the radical. So that square root of x minus 1 is on the side by itself. Second step is raise each side to a power. So it has to be the entire side. What would you have to do to cancel a square root? Square it. Okay, but when I square the x minus 7, what do I have to do? So you can't go through and just square individual terms. It's the entire side, so you have to write it twice in FOIL. So that's x squared minus 14x plus 49. We always set quadratics equal to 0. We subtract the x, add the 1. What multiplies to 50 and adds to negative 15? So we get positive 5 and positive 10. And what do we have to do now? Check it. If you plug in a 5, 5 minus 1 is 4, square root of 4 is 2, but 5 minus 7 is negative 2. So does the 5 work? No, 2 is not equal to negative 2. We put in a 10. So we get square root of 9, which is 3, equals 3. So 10 works. So my only solution here is 10. It's possible that they both will work. It's possible that neither one will. So you do have to check all of your answers. Are we okay with that one? Let's take a look at this one. I have 3 different radicals in this. We have to think of it as getting rid of one of them at a time. Okay, so if I'm starting with this radical right here, it is on the side by itself. So how do you cancel a square root? Okay, so if I square each side. What happens on the left, it cancels this outside square root. So we're left with everything that was underneath it. On the right, when you square, those cancel, and we get 3x plus 2. Okay, we still have a square root, so we're really kind of back to step 1, which is isolate the radical. You do have an option here. When I tell you to isolate it, we don't want things added or subtracted on the end, because then you have to FOIL with the radical, and we like to avoid it if possible. Here, I do have a 2 outside. And the only way to move that 2 over is to divide by it, which will give me a fraction. It's not going to make much difference either way here. Do you want a fraction or do you want to avoid it? Avoid it. Okay, if we want to avoid, we know we have to square each side. So what that means over here, you have to take the 2 squared and the square root squared. So we're squaring both parts. So 2 squared would become 4. And when you take the square root of 7x plus 2 squared, you just get 7x plus 2. On the right, because it's more than one term, if you have things added or subtracted, you have to think of writing it twice and FOIL. 9x squared plus 12x plus 4. If I distribute this 4, what would we do now? Subtract everything over to one side. So if we subtract the 28x, subtract the 8. If I want to factor this, we have to do slip and slide. Multiply to negative 36, add to negative 16. minus 2 and x plus 2. Then if we set those equal to 0, we get positive 2 and negative 2 ninths. Am I done? We have to check them. You're welcome, just use your calculator if you want. You have to plug in same number on both sides. So if I put in my 2, do you get the same thing on both sides? Everybody should be checking them, not just me. Yep, 2 works. Okay, check your negative 2 ninths. So, you check them, plug both of them in, left and right hand side have to be the same, and this time they both do work. Any questions on that one? How are we doing with these so far? I want to, I'm going to jump around for a second. I'm going to do this example next. Not that one. This one. All right. What does a 1/4 power mean? What is the opposite of a 4th root? If I take each side to the 4th. On the left, it cancels this radical. Alright, this becomes an x to the 4th. So if I bring everything over to one side, it's x to the 4th minus 5x squared plus 6. Alright, it's not a true quadratic, but we can factor it like one.
It would be negative x to the 4th plus 5x.
If you brought it over to the left, I brought these two over to the right to make my x to the 4th positive, but it's the same either way, yeah. What would x to the 4th break into? Okay. What multiplies to positive 6 and adds to negative 5? Negative 2, negative 3, because we need a positive 6, so the signs have to be the same. So that means x squared is equal to 2, or x squared is equal to 3. Okay, how do you get rid of a square? And anytime you have square root, you have to put plus and minus So we get x to be positive and negative square root of 2. Positive and negative square root of 3. So we don't have to have all nice pretty answers. Radicals work. And you are welcome to check these on a calculator. So if you put in 5 times square root of 2 squared minus 6 all to the 1/4. That has to be equal to the square root of 2, and that does work. What about when you put in the negative radical 2?
You don't have to put in the radical since it's squared. Can't you just put it
You
in
can put in a
parentheses?
2, yeah. If you put in a negative square root of 2, you can certainly use your calculator on these. But when you square it, it's positive. You get 5 minus, or 5 times 2, so 10 minus 6 is 4, so you get the 4th root of 4. And if you're using your calculator, you see this side is a positive. It actually turns out to be the square root of 2. But the other side is a negative. Can an even root, so if it's a 4th root, can it equal a negative number? No, they have to be positives. So you can use your calculator, or you might just recognize this is a 4th root, so it has to be equal to a positive number. So I don't care when you check them if you want to write them out, if you want to put them in your calculator, but you do have to verify those. And on this one, the 2 negatives do not work. So it's just square root of 2 and square root of 3 that turn out to be our solutions. I think I'm going to do 2 or 3 more for today, and then we'll pick up with some more examples tomorrow. Okay. So I want to look at least one more type for today. What would I do first? Any thoughts? How is this one different? Well, they're not the same thing under both radicals. So we have more than one radical, which we've seen before, but these, I don't have a radical on both sides. So when we have these, I told you want to isolate a radical. We want to get rid of one at a time. So let's get one of these radicals by itself to start. This would be 2 plus square root of x plus 2. Right? We know that if we want to get rid of a square root, we can square, but we have to do it on each side. On the left, these cancel. On the right, that means I have this thing twice. So what do I have to do? I have to FOIL that. So when we multiply, 2 times 2 is 4. 2 times the square root of x plus 2. Something must be on the root. So the 2 stays outside the radical. And multiply these. The 2 stays outside the radical. What happens when I take the square root of x plus 2 times the square root of x plus 2? It's like the square root of x plus 2 squared, so it cancels that radical. Okay, this is looking pretty ugly, but it's going to get better in just a second. This is the hard step right here, when you had to multiply with that radical. Now, we always want to isolate our radicals. So if we combine like terms, multiply those, you get 4 radical x plus 2 plus x plus 6. So if I'm isolating this radical, I can subtract over my x, subtract over my 6. What would you do here? We've had problems that started this way. Well, the 4 is a multiple.
You just have to, all you have to do is square it.
We have to square again. So these problems are a lot longer because we have multiple squares, or multiple square roots at the beginning. So we had to square twice. So when I do this, on the left, it means you have x minus 3 2 times. On the right, you have to square the 4 and square the square root. X squared minus 6x plus 9 equals 16 times the x plus 2. Now we have finally gotten to an easier equation to solve. If we distribute, that's 16x plus 32. Subtract over my 16. Subtract my 32. How would this factor? So we get positive 23 and negative 1. This is probably the hardest problem out of this section. So this is as hard as it gets right here. Because we have multiple squares that we have to add. And we do have to check at the end. When you're checking, you always go back to the original and plug them in. You can use a calculator, do it by hand, I don't care, but you have to check. So if you put in 23, you get square root of 49 minus square root of 25, so 7 minus 5 is 2, that works. We put in a negative 1, we get the square root of 1 minus the square root of 1. 1 minus 1 is 0, does negative 1 work? No. So 23 is my only answer. What questions do you guys have right there?
When it's 2x plus 3 equals, and when we squared it, where's the 2x go?
I subtracted over this x and the 6 to get my radical by itself. Other questions?
When you have the x minus 3, both of them together, and then you have equals the 4, where's the 4 coming from?
It was the coefficient in front of my radical to start with. We got it when we were FOILing the first time with the radical. So when you took 2 times that square root, it put the 2 in front.
Oh, okay.
And same thing here. So when you added them, 2 plus 2 gave you 4. Other questions? We're going to do one more like that and then I'm done for today. So you guys walk me through this one. Yeah, no, tell me what to do.
Okay, so you add for
Mhm. So we want to isolate a radical. So then what do we do? Square it. So on the left, the square would cancel my square root. On the right, we have to FOIL. So if you need to write it out. So first, 2 times 2 is 4. Outside, 2 times the square root of x minus 1 is 2 square root of x minus 1. Inside, square root of x minus 1 times 2, so 2 square root of x minus 1. Last, the square root of x minus 1 times the square root of x minus 1 just cancels our square root. So if we combine like terms, you add these square roots, you add their coefficients, so it's 4 radical x minus 1 plus my x, positive 4 and negative 1 is positive 3. Now we need to get the radical by itself, so we subtract over the x and the 3.
Where do the 2's go? Like the 2
These.
radical x minus 1.
You add them together. 2 plus 2 gave me 4.
What about the 4 before that?
I combined it with the negative 1.
square again.
Square root. So, on the left, you have 2x minus 2 twice. So that gives us 4x squared minus 4x, and minus 4x would be minus 8x plus 4. Over here, you have to square the 4 and the square root. So 4 squared is 16, radical x minus 1 squared is x minus 1. Bring everything over. 4x squared minus 24x plus 20. If we want to make life a little bit easier, what do you notice about all those? Got 4. What multiplies to 5 and adds to negative 6? Set them to 0, 4 never equals 0. If you set x minus 5 equal to 0, you get positive 5. X minus 1 equal to 0, you get positive 1. Alright, check them. So you're going all the way back to the original. Put in a 5. Square root of 16 minus the square root of 4. So 4 minus 2 is 2. That works. Put in a 1. Square root of 4 minus the square root of 0. So 2 minus 0 is 2. This time they both work. What questions do you guys have? There is a math Excel assignment. It is not due until Wednesday because I'm not finished with the section yet. If you want to know which ones we've really talked about, you could do 1 through 6, 12, and 13 all